Hi everyone, this is going to be a little mini lecture, really mini lecture, just because I wanted to review I made some changes to the code that I pushed online, so in case it doesn't match up with what you see in the videos, that's the reason. So first of all, I added an Iterator class to my linked list. The reason I did this is because I realized, well, maybe I don't want other people to know that I have these linked list nodes, like we talked about why we use an iterator. And so I've made an iterator that allows me to point to what part of my linked list node I have, and it also allows me to get the values at any given position in my linked list. So I can just use the iterator to walk down my linked list and return the value. So if I wanted to go back to my code here, let's do this. Let's go to my demo. I still have my stack demo I had before, but instead of doing a print statement, let's do a horrible print for the linked list and void. Let's call it horrible linked list print, and there's going to be a linked list, no matter what the linked list kind is, and PLL, great. And then what I'm going to do is I'm going to call PLL, I'm going to get the start. That's going to give me an iterator to the start of the linked list. And then what I can do is for each of these I can just essentially walk down this iterator. So while it, and it's a dot, while it's not at the end, if the thing is not at the end, then and even if it's at the end, I can do one last printf, I guess. So, and I'm going to do something horrible. So let's do cout horrible linked list print and endl. Actually, I'm not going to do the endl yet. Horrible linked list print. I'm going to go it dot get value. I'm going to cout and then let's use what kind of thing could I put in between dash, whatever. I'm just trying to separate these things out. So my it value is going to keep on getting a bunch of dashes, and as long as it's not at the end of my linked list, then I'm going to keep going, and then at the end I'm going to cout the it at the particular value, end of linked list. Now, this is not my normal paint method for my normal printing out method for a linked list, but it's something different. It will get me the start in my linked list. I need to do one other thing. I have an infinite loop here, so it dot next. I increment it, move on to the next one. Keep on going next. I can check to see if it's empty, and what other methods do I have in here? I can also get the value, which I just did. Alright, so that's all an iterator does. It points to the front of it, and then I can move that iterator down my linked list. I don't need to know what it is or what kind of link. If it is a linked list, it could be an array, or it could be some other data structure. The iterator just says, get me the next, get me the next, get me the next. I could even have get me the previous if I wanted to. And so my horrible print method here, I'm going to use this, and let's go down to my linked list, and for each one of these print methods, I'm going to do at the very end, instead of this kind, I'm going to do a horrible print linked list, and it's going to be taking, so it doesn't matter if it's a double linked list or a linked list, and I'm going to throw this in here, and I hope that this is going to work. So this is going to let you be using my iterator to print everything out. My iterator simply, if I go to, where's my iterator here? My linked list iterator knows about, it only knows about nodes, it doesn't know about the linked list itself. Actually, it has to temporarily make a connection to the linked list because I need to make it a friend class. The linked list is going to directly modify my iterator, so I can set where it starts. If I go to my linklist class, linklist.cpp, and I want to say, let's look for the start. Should be insert start, no, insert start, no, insert. Wow, I have a lot of things named start. All right, might be down at the bottom. Let me see. Here's my iterator stuff. Get the starting position. So it will give me an iterator to my starting position. So I make an iterator. I set the current node to be the starting position. Then I return it. So it just tells me where to start. I can even start it at the end if I wanted to, or get the end so that I know when I'm at the end of my iterator. Well, I could also have done a test. Is my iterator equal to the get end position? That would have also have worked. Okay, so I want to just look at how my code actually runs. Alright, everything works fine. Here's my horrible linked list print. 5, 6, end of linked list. Right, that's what I expected. Here's horrible print list. 4, 6. Remember, I'm removing a couple elements. So I have exactly 2 elements, these 2 elements here. Exactly 2 elements, these 2 elements here. So it's working as expected. It prints out in a different format than the other ways, but allows me some external thing to be able to parse and walk down my linked list without having to expose how a linked list is actually made. That's what I'm trying to point out, is that if I change the implementation of a linked list, you shouldn't be any wiser. You shouldn't have to know what a linked list node is, ideally. What I really want is, I put stuff in here, I take stuff out of there, I don't know how it's implemented, I don't care how it's implemented. Speaking of which, that's the reason, or the original reason why I started doing this refactoring, is because that's what I did here. What I didn't tell you, I warned you on last Friday, but for those 4 people that were there in class, if I have a stack, all it needs to do is it needs to push, it needs to pop, it needs to peek. If it looks like a duck and it quacks like a duck, then it's a duck. Or if it looks like a stack and acts like a stack, it's a stack. So what I actually have happening here is I've completely changed my stack definition to be something completely different than that array that we did before. I actually saved my old stack definition into my stack backup, but the new version of it, which I did not change anything about, none of the methods have actually changed, except this. All the methods are identical to what they were before. None of that has changed. Anyone using a stack is completely unaware of that would have made any particular change. The functions did not change. The implementation changed, maybe for better or for worse, but it does the same thing, acts the same way. You can't tell the difference between the two. That's the point. If I abstract away all of the minutia about how I implement this thing, then that's sort of the ideal situation. I make a stack, I don't need to know how it works, I just need to know how to use it. And so this is what I'm actually doing with my stack here. Is if I go to my, I need to find my stack here, .cpp, here's how I'm using it. It does nothing now because the linked list is already in there. It does nothing with the destructor. Linked list is already made. I don't need to worry about duplicating data. That was a private function before. Why? Because I knew when I was making it that I'm never going to have to use that again. If I happen to expose that function, if I made it public, and then I get rid of it, I could be breaking other people's code, and I don't want that. So anything that's implementation specific that other people do not need to worry about, I want to make it private, I want to hide it away. Anything that is specific that people need to be able to use, like push, for example, I make that public or protected at the most private, right? I need to be able to, other people are going to need to be able to use push, so I make it public. How it's pushing and how it's popping is irrelevant. It just pushes and pops. It's just some way of storing and taking things off. The implementation and the interface are different things. And that is really the art form to designing big object-oriented design projects. And I'm not saying my code is ideal, but this is one of those examples of why we have to think long and hard about how we implement things so that we don't expose weird aspects of our code, like linked list node, for example. Here is me here's me pushing something, I'm inserting something at the start. Here is me popping something, I'm removing from the start. I know, crazy. Here is me peeking, I'm going to get a particular value. This is actually why I needed the iterator, because I didn't have a way of getting a value from the linked list directly. So my peek is just going to get the value. Is it empty? Well, I can get the length of my linked list. Is it equal to 0? Or is it less than or equal to 0 because it's returning an integer? I want to print off my linked list. I use my iterator and I walk down my iterator like I did last time. But instead of using an array, I have to keep on walking down every element of my linked list. So my stack looks, acts, behaves exactly like what it did before. The only difference is I don't have to worry about dynamic arrays and resizing things. I'm just using a linked list, throwing things on the linked list, at the front of the linked list. If I had a queue, I could throw things at the back of the linked list and remove from the front of the linked list. And you don't have to worry about circular queues and stuff like that. Doing a queue with an array is actually much harder. I got to shift things around when I remove items, or I need to get a bit cutesy with the math. If I'm using a linked list, it's relatively easy. In fact, if I wanted to priority queue, I would just insert it in the right place and then remove from the front. As long as I have a linked list, it still works. So that's the big dead giveaway that I wanted to work on. So I'm going to stop the video now, but what we're going to pick up next time, I'm going to change all of my linked lists again. I'm going to copy it to another project. I'm going to change all of my linked lists and my stacks and all of this stuff so that it takes in a generic data type, not an integer per se, but some kind of data type T. T for template. And that's what we're going to be looking at, how we can template up this thing so it can take any kind of data that we want and it'll still work. All I need that template object type to do is to be able to compare which one is bigger, this one or that one. And that's what we'll look at next time around. All right, thanks everyone, thanks for listening, and hopefully you'll hear my voice soon.